All right, guys. I'm not really sure what's going on with my computer this morning. It is absolutely freaking out. So we'll see what happens. So yeah, that one video is supposed to start cut short, even if it posted. So we've got a couple of new things that we're going to be dealing with in the next couple of weeks, and one of them is dealing with the natural log. Remember, the natural log is really written as ln. That's an L, not an I. So the best part about natural log is it's like the quadratic formula. You can use it on any exponent or logarithm. Okay? That's the best part about these things. So we can use it on any exponent or logarithm. It doesn't matter. So when we are dealing with something like this, we end up with the exponent right here in the top part here. So if I was going to deal with something like this, I would actually tackle this. And what would you normally do? You would normally go log base 3 of 3, and that would disappear that, and we'd get 5t equals can't even think about it. 5t equals the log base 3 of 2. And then you'd have to divide both sides by 5. So this thing starts to look a little weird. So 5, we're going to divide by 5. And so now we get t equals log base 2 of 3 divided by 5. And then you got to figure out how to put this in the calculator. So that would be our answer for t, right? So, but if I look at something like that, and I go backwards here, and I come back to where I was, and I still want to solve for t, this is what I like about the natural log. I'm just going to take the natural log of both sides. So I get the natural log of 3 to the 5t equals the natural log of 2. So the problem kind of cleans itself up. There's no subscript. There's no anything. Now, a new property of, especially natural logs, is anytime you have something like this here, it moves out front once it's an exponent. So we're going to rewrite this as 5t times the natural log of 3 equals the natural log of 2. So all I did was it's a property, is that if you have a natural log that has an exponent in it, the exponent becomes the coefficient out front, which is right here. Now, you're like, that really didn't do much. It didn't. You get the same answer as you work, but it's a tool that makes problems a little bit easier, especially when you're dealing with a natural log, because if I rearrange this problem, let me find there it is. If I rearrange this problem here, I'm going to rewrite it. I'm going to put t in a different color. So I'm going to rearrange this. So I'm going to put t in that color. And then I'm going to move the 5 and the natural log together in another color, because they're all multiplications, so I can move them around. 5 times the natural log of 3 equals the natural log of 2. So now instead of getting this crazy looking final answer, you're going to get an answer I'm just going to divide both sides by all of this. So I'm going to say t is equal to the natural log of 2 divided by 5 times the natural log of 3. That's my answer. Using natural log and the properties help clean up the problems, okay? So that's why we use natural log that way. Makes it a little bit easier to deal with. Now, as we go, we get problems that look like this. E to the 4t plus 1 equals 5. And it says solve for t or k. K is a number there. So we need to solve for that guy. Well, we need to get rid of e, so we're going to take the natural log of both sides like we have been. And we're going to get 4t plus 1 equals the natural log of 5. And then we work our way and solve for t. So we're going to get 4t is equal to the natural log of 5 minus 1. And I'm going to divide the final part by 4. That gets rid of that, and we get t equals the natural log of 5 minus 1 over 4. Okay, so really working with natural logs, and it's just solving equations, so don't panic too much. But natural log, like I said, does sometimes clean up some problems for you guys. I like to use natural log. I really don't use log base 2 or log base 3 anymore. But other than that, good luck, guys, and we'll see you.